Lesson 39, difference of two squares, parallelogram proof, and rhombus proof. We're going to start off with the difference of two squares. Difference of two squares deals in factoring when we have a subtraction sign instead of addition sign. We're going to do this just by working through some examples. The first example is 81m squared minus 25. When we factor difference of two squares, the only thing that we do is take the square root of each term and make it into two binomials. So we're going to square root, first of all, 81. The square root of 81 is 9. The square root of m squared is m. And the square root of 25 is 5. Because we're doing difference of two squares, one binomial pair is going to be negative, and the other binomial pair is going to be positive. The pairs are going to be the exact same. The only difference is one sign is going to be negative and one sign is going to be positive. When one sign is negative and one sign is positive, when we distribute and multiply it out, it's going to cancel out that middle term and leave us with just a beginning term and an ending term and no middle term. Let's try another example. 144x squared minus 36. We're taking the square root of each term. So the square root of 144 is 12. The square root of x squared is x, and the square root of 36 is 6. Now we're going to have two binomial pairs. The pairs are the exact same. The only difference is one is positive and one is negative. That is finding the difference of two squares. Let's do one more example. This one I want you to do on your own. 121m squared minus 64. Pause the video, work this on your own, and hit play once you've come up with a solution. All right, your solution should be 11m minus 8 and 11m plus 8. We took the square root of each term, and then one binomial pair was positive and the other binomial pair was negative. Next, we're going to talk about parallelogram proofs. These are 4 proofs that deal with parallelograms. We're going to use these proofs to solve a problem later on. Number 1, the sides opposite each other have equal length. The sides opposite each other have equal length. Proof number 2, the angles opposite each other have equal measures. The angles opposite each other have equal measures. Proof number 3. The sum of the measures of any two consecutive angles is 180 degrees. And proof number 4. The diagonals bisect each other. Proof number 1, the sides opposite each other have equal length. Proof 2, the angles opposite each other have equal measures. Proof 3, the sum of the measures of any two consecutive angles is 180 degrees. And proof 4, the diagonals bisect each other. We're going to do a problem with these in just a minute, but first, I want to mention rhombus proofs. First, we need to know that a rhombus is a parallelogram, but it also has 3 additional properties. So in addition to the 4 parallelogram proofs, it has 3 other properties. So a rhombus is a parallelogram with 3 additional properties. Property number 1. All 4 sides have equal length. Property number 2. The diagonals form perpendicular bisectors. Which means that when the diagonals intersect, they form 4 right angles, which is proof number 3. The diagonals of a rhombus dissect the angles of the rhombus. So a rhombus is a rectangle with is a parallelogram with 3 additional properties. First one being a rhombus, in a rhombus all 4 sides are equal. The second one being the diagonals form a perpendicular bisector. And the third one being the diagonals of a rhombus bisect the angles of that rhombus. All right, we're going to use these proofs, the parallelogram proofs and rhombus proofs, to solve a problem. So take just a moment and go ahead and draw out this figure on your paper. Now in this problem, we're solving for A, B, X, and Z. Let's start off with solving for X and B, these 2 angles here. Now, we know that if this exterior angle is 360 degrees, or 306 degrees, and we continue this on with these 2 angles here, it forms a circle, and circles are 360 degrees. So we know that X and B, along with that 360 degree angle, form a circle that is 360 degrees. So we can solve for X plus B. X plus B is going to be equal to 54 degrees. Those 2 angles together have a sum of 54 degrees. Now, according to rhombus proof number 3, the diagonals of a rhombus bisect the angles of a rhombus. So this diagonal here, coming through B and X, bisects this angle. It splits this angle in half. So X and B are going to be the same thing. They're going to be half of 54. Half of 54 is 27. So X equals 27, and B also equals 27. Now let's work on finding angle Z. If we talk about rhombus proof number 2, the diagonals of a rhombus are perpendicular bisectors of each other. Now I know it doesn't look like it in this diagram because I can't draw. But these diagonals right here bisect perpendicularly, meaning that they form 4 right angles. So Z has got to be a right angle based on this proof. So Z is equal to 90 degrees. The last one we need to find is angle A. We're going to look at parallelogram proof number 3 in order to solve for this. Now, parallelogram proof 3 says that the sum of the measure of angles of any 2 consecutive angles is 180 degrees, which means that this angle here and this angle here, A and the one next to it, is going to be equal to 180 degrees. Now, we know that X plus B is equal to 54. We know that X plus B plus A plus this other little angle we'll call him Y. We know that all 4 of those angles are going to add to equal 180 degrees because they are consecutive. They're right next to each other. Now, if X plus B equals 54, we can then assume that A plus Y together are going to equal 126. Now, going back to Rhonda's proof number 3, we know that when a diagonal bisects, it bisects the angle. So that means it splits that angle in half. So A and Y are the same. They are half of 126, which means that A then has got to be 63 degrees.